This video documents an automotive air conditioning diagnostic case involving poor cooling performance. The vehicle is a 2017 Toyota Corolla, equipped with a 1.8-liter 2ZR-FE engine and a variable displacement electronically controlled AC compressor. The system uses R134A refrigerant, and ambient temperature during diagnosis was approximately 78 degrees Fahrenheit. The diagnostic objective is to determine whether the compressor is responding correctly to electronic control commands under normal operating conditions. AI narration is used to summarize and explain real diagnostic data captured during an in-field automotive AC inspection. The customer concern was insufficient cooling from the AC system. Vehicle history was reviewed with the customer. No prior AC-related repairs or recent non-AC repairs were reported that could influence system performance. The refrigerant type was confirmed as R134A. The system configuration was identified as a TXV-based system using a variable displacement compressor controlled by an electronic control valve, also known as an ECV. Environmental and HVAC command inputs were evaluated to confirm normal operating conditions. The ambient temperature sensor reported approximately 25 degrees Celsius, with an adjusted ambient temperature of 23.6 degrees Celsius. Cabin temperature measured approximately 26 degrees Celsius, and solar load input was minimal. Engine coolant temperature was approximately 90.5 degrees Celsius, confirming normal engine operating temperature. The driver temperature setting was set to maximum cold, and blower speed was commanded high, confirming full cooling demand. HVAC airflow and door operation were verified to rule out airflow-related limitations. Air mix servo target and actual pulse values matched, confirming correct blend door positioning. Air inlet and outlet damper target and actual pulse values also matched their commanded positions. These readings confirm that airflow distribution and blend control are functioning correctly and are not limiting system performance. Evaporator and compressor control data were then analyzed. The evaporator fin thermistor measured approximately 15.1 degrees Celsius, while the evaporator target temperature was calculated at 1.6 degrees Celsius. This indicates that cooling demand is present, but the evaporator is not reaching its target temperature. The refrigerant pressure sensor reported approximately 1,264 kilopascals, or about 183 psi, during operation. The compressor regulator control current measured approximately 0.8 amps, confirming that the control system was actively commanding compressor displacement. Mechanical compressor output was evaluated using manifold gauge pressures. Before repair, the high side pressure measured approximately 120 psi, while the low side pressure measured approximately 85 psi. This pressure pattern reflects minimal compression differential, which is not consistent with normal AC operation under active cooling demand. Elevated low side pressure combined with low high side pressure indicates weak refrigerant compression and reduced mass flow. After repair, gauge readings changed significantly. High side pressure increased to approximately 200 psi, while low side pressure decreased to approximately 35 psi. This restored pressure separation confirms normal refrigerant compression, proper mass flow, and effective heat rejection under the same ambient conditions. In a variable displacement compressor system, electronic command input should result in proportional mechanical output. In this case, scan tool data confirmed correct electronic command, while pre-repair gauge readings showed inadequate compression. Once mechanical function was restored, normal pressure differential and cooling performance were observed. This data pattern is consistent with compressor under-displacement rather than an electrical control, airflow, or refrigerant management fault. Based on environmental inputs, HVAC operation, scan tool data, and before and after pressure measurements, this case is classified as a variable displacement compressor under-displacement condition. This video documents diagnostic classification and validation only and does not determine or authorize repairs.